Okay, and welcome to our next video on coordinate geometry. And particularly, we're looking at the equation of a circle. And in this one, we've already gone through the basics, so you should have already seen how the equation of a circle works. And in this video, we're going to be looking at problems involving intersections, lines, tangents, normals. So here we go. First of all, intersections of lines and circles. So you should be well aware by now of the discriminant in the quadratic equation, how that links to intersecting lines and curves. And with regard to lines and circles, the principles are exactly the same. So if we've got a straight line going through a circle, clearly we've got 2 points of intersection. So we've got 2 distinct routes. So what we know is that the discriminant in that particular case, b squared minus 4ac, will be greater than 0. The next situation that could occur is when we've got the straight line as a tangent to the circle, i.e. it just touches the circle in one point without actually passing through it. So that's one similar to when we've got a repeated route or 2 routes occurring in the same place. For that one, b squared minus 4ac is equal to 0. And then finally, the last one is when they don't intersect and clearly no routes. So we've got b squared minus 4ac is going to be less than 0. So in a number of cases, you might be asked to use these facts to determine number of routes or prove the relationship between a particular straight line and a circle. So here we go. As I just said, we've got to show that this straight line here is a tangent to the circle, and there's the equation of our circle. And then in the second part, we've got to find the equation of the normal to the line. So let's just worry about part A now to begin with. So here we go. Right, we need to find where they intersect, so we need to solve essentially these 2 equations simultaneously. And as it says there, the easiest thing to do is to take this first equation, rearrange it so it says x equals, and then substitute that in. So there's the rearrangements. X is 2y minus 22. And so what we're going to do now is take this bit here and chuck it in place of the x in our circle equation. So there's our circle equation. There it is when we've chucked it in. That's what we're going to end up. So all it does is just tied it up inside the bracket. And by this point in the course, you should be capable of multiplying out brackets and tidying it all up. And so I've kind of missed that section out. We're just going to jump straight to the final equation, which, as it turns out, is that y squared minus 18y plus 81 equals 0. Like I say, if you want to check that works, then feel free just to pause the video and have a little play around with the squared brackets here. And like I say, you should be able to rearrange it to get to there. If you've done that and you're happy with that, let's move on. So we know that our line and our circle are going to intersect at some value of y that satisfies this equation here. And we're told that it's a tangent. So what do we know about this equation here? Well, we know that b squared minus 4ac hopefully should equal 0. So that's what we've got to prove. So let's see what happens. So b squared minus 18 squared minus 4 times 1 times 81 is 324 minus 324 equals 0. So there we go. We've proved it. But again, you've got to make sure that you're telling the examiner you know what that means. So we've got to put in a statement there saying b squared minus 4ac equals 0. So therefore, we've got 1 point of intersection, or 1 route, which means that the line is a tangent to the circle. Okay, and on we go. So we've got to find the equation of the normal to the line x minus 2y plus 22 equals 0. So the normal line is the one that's perpendicular to it. So we need to find the line that's at right angles to that at the point where it goes through the circle. So we proved that it was a tangent, but we need to find the coordinates where it goes through the circle. So we know that the coordinates where it hits the circle is the y coordinate is going to be given by that equation from our previous slide. Do a bit of solving. So we've got y equals 9 and x equals minus 4. So we can find the coordinate where the line hits the circle. And so now we've got to find the equation that goes through there at right angles. There's a couple of ways we can do this. First of all, we can use perpendicular gradients. So if we take our tangent, there it is, and just find the gradient of that and use m1, m2 equals minus 1. So there's the rearrangement, make it say y equals. Means we've got a gradient of half, which means our perpendicular gradient, or the gradient of our normal line, is going to be minus 2. And if we know that the gradient is minus 2, we can just plug that all in into y minus y1 equals mx minus x1. There it is. And tidy it up, and there we go. Our normal has got the equation y equals minus 2x plus 1. So that would be one way of doing it. But I'm going to show you another way as well. So you don't have to do both every single time, but let's say you've just got a choice. I'm just showing you other ways in which you can go about things. And depending on how the information is presented to you, this method that we've just looked at might be better, or it might be you've got different information and you need to use our second method. And here we go with our second method. And our second method just uses a little bit of knowledge about angles and circles. So what we're saying is that if we've got a line that's at right angles to the tangent, then it's going to go through the centre of the circle because the radius meets the tangent at 90 degrees. So what we need to do, therefore, is find the equation of the line that goes through -4,9 and the centre of the circle, which we know from the equation is at -1,3. We can see that from the coordinates of our equation, sorry, from the equation up here. So what we're going to do now is just find the equation of the line that goes through those 2 points. So there's our formula for the gradient -2, and then put that back into the equation of the line, and there you go, we end up with exactly the same equations before, obviously. So it's just two ways of achieving basically the same thing. Right, moving on. Here we go, another example. Now I'll turn out this one is a real bit of a shocker, but I chucked it in because it gives you an idea of kind of how you might want to attack some kind of problems when they're chucked at you. They're not always going to be exactly the same, so you've got to think very carefully about what information you've got, what you use, how you can apply the skills that you've got. So what we've got is the equation of the circle, and we've got two lines that are tangents to the circle, and those two lines meet at the point 0,12, and we've got to find out the equations of both of those lines. So here we go. Well, for both lines, we know that in the form y equals mx plus c, we're given effectively the plus c, we're given the point where it intersects the y-axis. So we know that both lines are in the form y equals mx plus 12 for some value of m. So what we can do is say, well, effectively, if we want to work out where these lines intersect, what we'd be doing is taking the mx plus 12 bit and putting it in for our value for y. So all I'm going to do is substitute there. So it's a similar technique to what we did before, but just with this general equation, this mx plus 12. Do some multiplying out. And so we can see that this section here comes from the x minus 6 all squared. This section here, again, I've just jumped a step, but if you just tidy that up, you've got mx plus 7, and then you can see where the m squared x squared plus 14mx plus 49 comes from. So what we could do now is just get that as an equation in terms of x. We're just going to tidy it up a little bit. So gather together x squared terms, gather together the x terms, and gather together the constant terms. So it looks like our standard form for a quadratic equation. So our x squared, I've got 1 here, and I've got m squared lots there. So I've got 1 plus m squared lots of x squared. Hopefully that makes sense. And then how many lots of x have I got? Well, I've got minus 12 here, 14m there. So there's minus 12 plus 14m. And then the constant terms, let's say we're going to bring the 17 over, combine it with the 36 and the 49, and we end up with 68. So again, that thing doesn't quite look like it, but that is our general formula for a quadratic equation. So we can apply the quadratic formula. So we've got values of a, b, and c, and we know if the lines are tangents, then we know that b squared minus 4ac equals 0. So there you go. A is 1 plus m squared, b minus 12 plus 14m, c is 68. So if we use b squared minus 4ac, that's what we get. B squared minus 4ac, and then tidy that up, and we end up with this horrible looking quadratic, which tidies up a little bit more nicely. So we've got 19m squared plus 84m plus 32. We know it equals to 0 because we know the lines are tangent. B squared minus 4ac equals 0. And if we solve this, and again you can grab your calculators and solve it however you want, either factorise or quadratic formula. As it turns out, we'll factorise, but I suspect quadratic formula is probably easier in this one. We've got values of m that are minus 4 and minus 8 over 19. If we look at our diagram, you can see, yeah, that seems to make sense because L1, that's got a negative gradient. L2, that's got a negative gradient. So these values of m seem to be working. So now, if we go back to our original y equals mx plus c, we had y equals mx plus 12. Put in the values for m, and there you go. There's your two equations of the line.